When you look up at the night sky, Earth is just a pale blue dot, one of billions. But there's one thing that makes it unlike any other planet we've ever found. Fire. Not just heat, not just energy, but fire that breathes and changes everything. Here's the crazy part. Fire only lives on Earth. Not Mars, not Venus, not anywhere else. Why other planets lack fire? The key is oxygen, and most planets just don't have it. Mars, for instance, has a thin atmosphere made mostly of carbon dioxide and barely any oxygen. Its low pressure and dry surface mean fire can't catch or spread. Venus is even more extreme, with a thick, toxic atmosphere full of carbon dioxide and sulfuric acid clouds, but no oxygen to feed flames. Plus, its surface is scorching hot, too hostile for fire as we know it. Gas giants like Jupiter and Saturn are mostly hydrogen and helium with no solid ground or oxygen, so fire simply can't exist there. Titan, Saturn's biggest moon, holds enough methane and nitrogen within it to prevent free combustion. There is simply no free oxygen among the elements needed for combustion. In short, Earth's unique oxygen-rich atmosphere and right conditions make fire a rare and special phenomenon in our solar system. Storms rage on alien worlds. Lightning strikes, but no flame ever takes hold. For hundreds of millions of years, fire has sculpted Earth's forests, rewritten our atmosphere, and even helped fuel human evolution. But what is fire, really? Why can't it exist anywhere else? And how did this miracle become the spark of life itself? Subscribe, because this is the story of fire, like you've never heard it before. What is fire? To truly grasp why fire is unique to Earth, we first need to understand what fire really is, and it's far more fascinating than just a flickering flame. At its core, fire is a rapid chemical reaction called combustion. This happens when a fuel, usually carbon-based, like wood or fossil fuels, reacts with oxygen, releasing heat and light. But not everything glowing or burning is fire. Take the sun. It's not burning like fire, but is a massive ball of plasma powered by nuclear fusion, where hydrogen atoms collide to form helium, releasing enormous energy. Lightning isn't fire at all. It's merely a huge electric spark having a flashy tantrum in the sky. Even volcanic lava isn't fire. It's molten rock, heated to extreme temperatures. What sets fire apart, though? It needs three things: fuel, oxygen, and heat. When these come together just right, the fuel's molecules break apart and react with oxygen, releasing energy that heats the air until it glows, that glowing flame we see. Fire's bright glow exists only because of the oxygen-rich atmosphere here on Earth, making it a rare and extraordinary phenomenon in the universe. Why fire requires oxygen? So, now that we know fire absolutely needs oxygen to burn, here's the big question. Why does Earth have so much oxygen in its atmosphere when almost nowhere else in our solar system does? That one gas is the sole hidden ingredient that creates the possibility of fire and makes Earth very unique compared to other planets. Imagine traveling back billions of years to a world that looked nothing like the one we know. The air wasn't fresh or full of life. It was a thick, choking mix of volcanic gases like carbon dioxide, methane, ammonia, and water vapor. There was practically no free oxygen floating around. In fact, any oxygen that did exist was so reactive that it immediately locked itself away by bonding with iron and other elements. Fire? Forget about it. You couldn't even light a spark. But then something beyond belief occurred about 2.4 billion years ago. A moment so powerful it literally changed the course of life on Earth. And it's the story of how tiny, invisible organisms transformed our planet's atmosphere and made fire possible for the first time. Now let's zoom in on the incredible event that changed everything, the Great Oxygenation Event. Imagine tiny, ancient microbes, cyanobacteria, living in the primordial oceans, quietly going about their business. These weren't just any microbes, they evolved a superpower called photosynthesis. Using sunlight as a magic energy source, they took in carbon dioxide and water, and as if by some cosmic alchemy, produced sugar to fuel themselves and released oxygen as a sparkling byproduct. This process might sound simple, but over hundreds of millions of years, it was nothing short of revolutionary. These microscopic oxygen factories pumped out vast amounts of oxygen, transforming not just the oceans but the entire atmosphere. But here's the twist. Initially, that oxygen didn't just float freely in the air. Instead, it got mopped up by dissolved iron in the oceans, creating huge deposits of iron oxide, which we know today as the iron ore we mine. This oxygen sink acted like a giant sponge, soaking up all the free oxygen until it was full. Only after these sinks were saturated could oxygen finally start to accumulate in the atmosphere. When it did, it reached levels high enough to support a new phenomenon: fire. Without this ancient oxygen boost, fire as we know it simply wouldn't exist. It's wild to think that the fiery flames we see today owe their existence to these tiny microbes' photosynthetic feats billions of years ago, when fire first appeared on land. So, with oxygen finally abundant in the atmosphere, what happened next? Let's travel forward in time to around 420 million years ago, when life was taking its first big steps onto dry land. The fossil record tells us that this is when fire began to flicker on Earth's continents for the first time. Before this moment, Earth was basically a watery planet, with no green plants or forests to fuel a blaze. The earliest land plants were tiny and simple, like mosses and liverworts, but they laid the groundwork. Over millions of years, these plants grew bigger and more complex, eventually forming sprawling forests teeming with biomass, exactly the kind of fuel fire needs to spread. But how did these early fires ignite without matches or humans? Nature provided the spark: lightning. Electrical storms, generating lightning bolts hotter than the surface of the sun, would streak across the skies, striking dry plants and trees. These powerful flashes ignited the vegetation, sparking the first wildfires. These ancient fires weren't just destructive, they shaped ecosystems, helped recycle nutrients, and even influenced the evolution of plants and animals. It's fascinating to imagine that the fiery dance between lightning and forests began hundreds of millions of years ago, setting the stage for fire's critical role in shaping life on Earth. Fast forward to around 300 million years ago to a time known as the Carboniferous period, often called the Golden Age of Fire. Back then, Earth's atmosphere was dramatically different from what we breathe today. Oxygen levels soared, possibly reaching as high as 35% compared to today's 21%. This rich oxygen environment made fires burn hotter and spread more easily, turning wildfires into massive, roaring infernos that could sweep rapidly across vast, ancient forests. These forests were unlike anything we see now. They were dominated by giant plants such as lycophytes, horsetails, and ferns, ancient relatives of modern trees. These towering plants created dense, lush landscapes filled with thick layers of vegetation. But there was a plot twist. These plants didn't break down quickly after they died. Instead, their remains piled up in swampy wetlands where low oxygen levels slowed decomposition. Over millions of years, this buildup of dead plant matter was compressed and transformed under layers of sediment, eventually becoming the vast coal beds that we still mine today. This timeless interplay between flame and forest during the Carboniferous period not only shaped Earth's ecosystems, but also laid the groundwork for the fossil fuels that have powered human civilization for centuries. Fire hasn't just shaped landscapes, it has been a powerful force driving the evolution of life itself. Over time, many plants developed clever adaptations to survive and even thrive in fire-prone environments. Some grew thick, insulating bark that shields their vital tissues from intense heat. Others developed seeds that only sprout after a fire's heat cracks them open, a brilliant survival strategy known as serotiny, ensuring the next generation grows in freshly cleared, nutrient-rich soil. Numerous plants have the ability to rapidly grow back from their roots or base after a fire, giving them a head start over other species. But plants aren't the only ones shaped by fire. Animals, too, have learned to live with and even exploit fire's power. Certain mammals use recently burned areas where new growth is tender and abundant as prime feeding grounds. Fascinatingly, Some birds have been observed using fire as a hunting tool. For example, the Australian black kite and other birds of prey sometimes pick up burning sticks and deliberately spread fire to flush out insects and small animals, turning wildfire into a weapon for survival. This ongoing relationship between fire and life highlights how intimately connected Earth's living beings are to this dynamic force, influencing ecosystems and behaviors in ways we are only beginning to understand. Is fire plasma? Many people wonder if fire is plasma. While fire shares some characteristics with plasma, they aren't quite the same. Plasma, being the fourth state of matter, is an ionized gas consisting of charged and neutral particles that can conduct electric current and respond to a magnetic field. In flames, temperatures get high enough to produce tiny pockets of plasma, but fire itself is primarily a chemical reaction, molecules burning and emitting light. Unlike the fully ionized plasma of the sun or lightning, fire contains only small amounts of plasma in its hottest regions. This subtle difference helps us appreciate fire not just as a physical phenomenon, but as something deeply connected to life, especially human life. Around 1 to 1.5 million years ago, humans learned to create and control fire, marking one of the most transformative moments in our history. Fire gave our ancestors warmth against cold nights, protection from predators, and a way to cook food, unlocking more nutrients and making digestion easier. It also allowed early humans to craft tools and pottery, while becoming a gathering point that fostered social bonds and culture. This newfound mastery of fire helped us expand into new environments and build the foundations of civilization. As important as fire has been throughout history, it remains a powerful force today. In the present day, fire continues to play a vital role in both nature and human society, but it also presents challenges. Wildfires, once natural parts of ecosystems, have become increasingly severe due to climate change and human activity. To manage these risks, controlled burns are used to clear excess fuel and prevent larger, uncontrollable fires. At the same time, scientists study fire behavior to improve safety and protect ecosystems. Fire's story is ongoing, and its future will depend on how wisely we learn to live with and manage this elemental force. Fire is Earth's ancient ally, a rare product of life, oxygen, and fuel, working in perfect balance. It's a force that has shaped landscapes, driven evolution, and illuminated our human journey. No other planet in the solar system hosts this fiery wonder. The Earth is not just the blue planet, it is the only one where the fire exists. So next time you see a flame flicker, remember, you're watching a chemical miracle born from billions of years of Earth's history. If you enjoyed this deep dive, don't forget to like, subscribe, and hit the bell for more incredible stories from science and nature.